All right, last we are talking about solving compound inequalities. So compound inequalities are awesome. When you think about compound, the word, something I often say in my math classes is that in math, we're not creative when we name things. We tell it like it is. And so compound inequality, compound, when you think about it, like joining some things together, right? So a compound inequality is an inequality that is formed by joining two inequalities with the word or the word and. All right, so here's what's what. On the left-hand side, we've got the or side. So an or inequality literally has the word or in it. So you'll have two different statements here. X is less than -2, or you'll have X is greater than or equal to 3. All right, so what we're going to do here is graph those separately. So we're going to have an open circle here at -2, and X is smaller than that, so pointing away, or to the left. I'm giving away some information here. All right, and then for X is greater than or equal to 3, we're going to look at putting a closed circle at 3 because no. Okay, closed circle 3. And moving to the right because it could also be bigger. So what we have going on here, we have these two branches of the inequality, these two rays pointing away from each other. And that's always what you're going to see here with an or inequality, right? Because it's like, well, it could be over there, but it also could be over there. So this is what's in our solution set, right? And then it's made up of those two branches there. Right, next we have and so this is, you might be like, I don't see an and in here. This is what I lovingly refer to as a sandwich inequality, and it's made up of two different statements here actually. So what you'll see happening here is we have this statement here, which I'm going to rewrite it a little bit. It says X is greater than or equal to -1. All right, and then we have and then this statement here, X is less than 4. So what we're looking for is an area where both of those things are true. That's what we mean by that word and there. So let's go ahead and graph these and see what happens. So X is greater than or equal to -1. If I fill that in there, take that, scribblers, and I draw my arrow to the right. That's that one. Now here, I'm going to have an open circle at 4. And that would actually go to the left. And so you'll notice that there's this bit here, right, where these overlap. And so that's actually what we'll graph in the future. You'll see that in an upcoming example. But it's just that segment where they're connected. So that right there is our solution set because those are the values that make both of those inequalities true. Over here on the left-hand side with the or, they can't both be true at the same time, right? It's either on the left-hand side or it's on the right-hand side, but it's not on both, right? There's no values that make both of those true. But on the right-hand side, we're looking for where are both of these pieces of information, both these statements true at the same time. And so that's why we're looking for that overlap there. All right, so let's look at some problems. So this first one is that little sandwich, and and it's got two statements attached to it. So this first one here looks like, oopsies, this negative 4 is less than x. So if it takes you a second, right, you can always say x is greater than negative 4, like rewrite it. Totally fine. So that means is that negative 4, I'm gonna draw an open circle. And I'm gonna start by drawing like a little arrow showing me where I'm going. Not quite, but just to remind me of the direction. Then, this is my pro tip, if you will. Then over here, we've got x is less than 3 or equal to 3. So this is going to have a closed circle at 3. And it's going to be going to the left. And so how I'll actually draw this is I'll take a little segment and connect those two vertices, those two endpoints there. Oh, okay. That is the graph of our inequality. All right, now let's look at an or. So same thing here. I've got x is less than 1, or I've got x is greater than or equal to 3. So for x is less than negative 1, I'm going to put a circle right there. And so we want smaller than that. Or x is greater than or equal to positive 3. So again, close circle there, and then we'll go arrow to the right, like so. All right, go ahead and flip the page, and let's see how we might go about solving some of these. So we can solve compound inequalities by solving two inequalities separately. So when solving an inequality with this and, right, that's written as a single inequality. So what I mean is that sandwich type. So if you write sandwich in your notes, like, it's fine. That's legal. All right, so you can solve those by performing each inverse operation on each expression. So I think that's kind of fun, right? So let's solve one of those first. So here we have an and, right? So I have two symbols here. I've got negative 2 is less than 4x plus 2 is less than or equal to 10. So what's going on here? So I'm going to solve together. And it's going to work just like before, where I'm going to use my inverse operations. So I need to get rid of this adding 2, so I'm going to subtract 2. But I'm going to subtract 2 everywhere, in all three expressions. So I'll have negative 4 here. I'll have less than 4x is less than or equal to 8. Now I need to get rid of multiplying by 4, so I'll divide by 4 everywhere. So I'll have negative 1 is less than x, which is less than or equal to 2. All right, so let's go ahead and graph this. So at negative 1, I have an open circle. Negative 2, or at positive 2, I have a closed circle. And I'm going to connect those. And there you have it. All right, next we have an or, and so these I'm going to just solve separately. All right, so it's just like solving two problems for the price of one. So let's start with this one here on the left. I'll subtract 5 from both sides. So I have 2x is greater than 14. Now I gotta divide both sides by 2 to get x alone, and if x is greater than 7. So that's going to be one of my inequalities. And here, let's just do this one blue. So this is greater than 7. An open circle here, and I'll graph it. All right, now we need to solve this one. So this one just looks like a one step. I'll add 3 to both sides. I'll end up with x less than or equal to 1. And that's it. So this one I'll graph blue just so we can kind of see which is which. Then don't forget to put that or back in the middle of your answer, right? So x is greater than 7 or x is less than or equal to 1. All right, next we are going to solve and graph these inequalities. Okie dokie. So first one is an and. Let's go ahead and add 4 to all sides. 4 is less than equal to 5x, which is less than 20. Then we're going to divide by 5 everywhere. So now we have 4/5 less than or equal to x, which is less than 4. Now let's go ahead and graph. So 4/5, right, is pretty close to 1. So I'll have a closed circle here, pretty close to 1. An open circle at 4. So, all right, and then this last one is an or. So, subtract 5 from both sides. Negative x is greater than negative 1. I need to multiply both sides by negative 1 to get rid of that negative over here. And when I do that, I have to flip my sign. That's going to actually end up with x is less than 1 over here. So open circle at 1, less than, like so. And then I'll write my word or so I don't forget. It's funny looking or. And then over here, I'm going to just multiply. Here, I'll rewrite it. So it's easy. Both sides by 3. Since I would have to, if I divide it by 1/3, multiply by the reciprocal. Anyways, work smarter, not harder. So we get x is greater than 6. Also going to have an open circle. And then bigger than that. All right, y'all, we are done with solving inequalities for Algebra 1. You did it.